Hello and welcome back, guys, to this second partial in mathematics. I'm gonna be with you in this time, and it's gonna be a little bit different. I hope you had a good time with your family, sharing time to cooking, sharing time to being talking and doing things we normally don't have the time to do, but it's a good time to share. And I want to share with you many of the knowledge that I have related with mathematics, of course. And for that, we're going to use many internet tools because this is what we have right now. And I'm going to be with you this time, this second partial, and I want to tell you and share with you how it's going to be evaluated and the distribution of some of the contents. So guys, nice to see you again. I hope we have a good time in math, and I hope you're still having the same pretty good attitude in this situation. So God bless you and your families too. Let's start. Okay, here we go with the description of the class. Mathematics, this second partial. How's gonna be the class? Okay, I'm gonna start talking about the evaluation. Some important points you have to consider because of the result I saw in this first partial. Okay, talking about the second partial, there will be 10 weeks of classes from April 20 to June 24th. Every week, you will be evaluated with a homework, online quiz, or an investigation. Of course, in my class, I will concentrate in these three types of assessment, and I'm gonna tell you in what consists each one. In mathematics, every assessment will be evaluated with 10 points. You will present the assessment during the week that is assigned, taking Saturday like the last day to send your assessment. So you're gonna have the whole week to present your assessment. And please try to be punctual. Assessments that are late will cost the half of what it is. So if its assessment is 10 points, you're gonna have an evaluation less than 5 if it's the case. But I'm saying this right now because I don't want to have students that fail in assessments, and you will see the assessments will be very short. An assessment that have 5 or at most 10 questions or exercises like the one you did this last partial. I will try to send you Word documents and in where you just have to like write the letter of the answer, but follow the instructions, please. It's something important for me. Every assessment must be sent in a Word document or PDF, excepting the online quizzes. The online quizzes, some of you have the experience. I think it's a good idea. Use this tool and you will do like 2 or 3 online quizzes. You will see this in a few minutes. If you need to send a mail, write in the email subject your name and grade. Of course, the section 2. It's very important for me because some of you send emails and this goes sometimes to the spam of the email and I can't open it. Or sometimes you send works or homework from emails that are not yours and you don't write the name. This is something important too, that there is a mandatory information you have to write in this kind of works or homework or assessment. It's your name. It's very important. You have to write your name every time. Okay, here is the distribution of the activities I'm expecting to do with you during this second partial. If you see, there are the 10 weeks, and practically I'm gonna work with 3 types of assessments: investigations, homework, and online quiz. So, how's gonna be the investigation? Something you can Google immediately, or something that maybe you will use an online application or an online website in order to solve the exercise or the questions related with that investigation. Homework, how the homework is gonna work. The homework's gonna work like the study guide you did, or like the activity one you did in like the last week or in those days. It's very interesting because all you need to do is solve the exercises and write the answer. Practically, I'm gonna check more answers than procedures. But of course, one of the most important thing here is show me your evidence. So in each of the homework or in each of the investigation, you will send some picture of you doing the exercises as evidence that you were working. Okay. In the online quizzes, you will not have any trouble. It's something that you can answer in your cell phone or in your computer. I will share with you a link, and you will go to that link and you will see how's the quiz. The quiz is very easy. It's multiple, single choice. Sometimes is just write a number, but the situation is something that you can solve. So here you have week by week the activity or the assessment that I want that we do. Of course, each one is 10 points, like I said in the other slide. Okay. In assessment, please follow the instructions. If the instruction requires that you write your name many times, do it, please. Write your name, section, the date, etc. Please, before you send or upload your assessment, be sure that you already filled the information. Why this is so important? Okay, assessments without name will not be evaluated. Why? Okay, because you must guarantee that the work you send is yours. Okay, copyright or no copy. Practically, this is the policy that I want to apply. No copy. If you mistake sending assessments that are from other classes, you should read the comments. I will write in each assessment evaluated, but don't let the time pass. This is what happened with some of the students. Of course, I'm working with 9, 10, and 11th, and I saw that some students mistake on it and send me works from other classes, from physics, for example, or from other classes like symbolic logic in 11th. And it's not my job. I mean, my duty right now is teach you math, and it's not easy at all. But I'm gonna use those tools in order to make this easier for you and understandable too. Okay. How's gonna be the dynamic of the classes? Practically, we're gonna have 2 or 3 classes per week. You will explore a YouTube video or a guided activity or sometimes a Zoom session. I will try to make some sessions with you, and something that happened with Zoom is that it's not available to work with more than 50 students, and practically sometimes stop working if there are 30 persons in that session. So that's why I will use more this session of Zoom in order to attend questions and doubts about the topics, of course. And probably I will make one session like this each 2 weeks. I will share the link, the Zoom link in the platform. So what does it mean? It means that you need to have this application in your cell phone and in your computer, or in your computer if you're using a computer. So this is all, guys, and I'm gonna explain you right now the contents. I will study with you the second partial. Thank you. For 10th graders, sections A, B, and C, the contents for this second partial will be chapter 10, chapter 1, and chapter 2, in that order because we had to conclude the idea and the content related with trigonometry. Of course, using the same book, Algebra 2 from Larson. Chapter 10 is about the trigonometric functions. Chapter 1 is about the quadratic functions and factoring. And chapter 2 is about polynomials. Chapter 10, we will conclude the idea of the trigonometric functions with a graph of each one. And of course, we will study the transformation it can suffer according with the degrees or radians, we change in the graph. Here's an example of the use of the unitary circle in order to make or to construct the graph of one of the trigonometric functions. This is part of the work we're going to do related with this content. Quadratic functions and factoring. Something interesting in algebra, it's talk about a quadratic function, specifically the graph of this one and how to solve equations related with this. One interesting and most important skill you must have as a student in 10th grade is factorize. So we're going to review this idea of factoring, applying some of the basic methods in order to factorize polynomials that has degree 2, which are the ones called quadratic polynomials. In talking about the polynomials, in essence, we will conclude when something is polynomial and when something is not, and of course the elements that they have, and something else, something more interesting, is how to solve a polynomial equation. Because remember, the main goal of this year, 10th grade, is solve any kind of equation. Okay, 10th graders, we're going to start with this first class talking about the trigonometric functions. Of course, we're going to start with the elements we require to keep in mind to understand better this content. I'm not going to give you the topic like in once. No, I'm going to start with the tools you need in order to understand how the trigonometric functions works. So the dynamics for these classes will be every time I will present you the content, the objectives, we're going to develop the content, we're going to do some practice, and we're going to make the conclusions of the class. So for this class, we have to keep in mind the unitary circle, we need it, so please check it. You must be sure you have all the values correct. And please have it in your hands because it's going to be useful, specifically for one part of the homework you're going to have for this week, part of the investigation you're going to have for this week, because you're going to do a graph your own, yourself. And it's part of the objective here. So objectives. We're going to use the unitary circle to conclude the values to construct the coordinates of the trigonometric functions. You already did something related with this objective. You will see it later. Count fractions, in this case radian units, to separate the x-axis. Make the division of the x-axis in radians to graph trigonometric functions. Conclude the shape of sine trigonometric function. We're going to do it in this presentation, and you're going to conclude by yourself the graph or the shape of cosine trigonometric function. Okay, starting with the first tool you need is you need to be sure if you can count in radians, if you can count like dividing a number or dividing the number line in fractions. So be careful with this. You can count radian by radian. Just remember that radians works like fraction. And if the fraction can be simplified, you must do it. You must simplify it. So we're going to do an exercise right now, a little practice in order to understand this better. How can you count from 0 radians until 2 pi radians, counting pi half radians by pi half radians? How is that possible? Okay, let's see how that works. And it's not going to be complicated, to be honest. You need to count 1, 2, 3, so on, like you normally do. But keep in mind the idea that you have to simplify. You must simplify if it's possible. Don't miss this important idea. Okay, let's start. Starting the counting, here we have 0 pi. Okay, of course, we're supposed to start with 1, but I'm going to start there with 0 pi, which is 0 at the end. Then, continue with the counting, 1 pi and a half. So next of 1 pi and a half is 2 pi and a half. Continue with the counting, 3 pi and a half. Continue, 4 pi and a half, and I'm gonna stop there because I'm sure until there I already reached 2 pi. Of course, I can continue counting, 5 pi and a half, 6 pi and a half, 7 pi and a half, and so on. and construct all the positive x values in the x-axis, okay? But I'm not gonna do it. And if you see here, there are some values that can be simplified, so be careful. Be careful with this. I will not accept countings like this for the what we're gonna do. So you must simplify some of the fractions. In this case, 2 over 2 can be simplified, and 4 over 2 can be simplified too. Something interesting about this one is that you don't need to write the 1. And we will see it in the next slide. So here we have the first one. So 0 pi is the same as you have like 0, no problem. 1 pi and a half is the same as you have just by half. So it's better to represent 1 pi and a half or 1 pi third or any other 1 pi over another number, just like pi over the number, because by that way it's already understood that you're doing 1 pi. Next one is 2 pi over 2, which can be simplified as said, and it's exactly pi. 3 pi and a half can't be simplified, so it's already simplified. And 4 pi over 2 or 4 pi half is exactly 2 pi. And if you see the counting here, it's now from 0 to 2 pi, counting pi half by pi half. So the counting at all, it's in here. So how can you count with radians? Easy. All you have to keep in mind is make the counting normally first and then simplify. Final counting is 0, pi half, pi, 3 pi and a half, and 2 pi. Practically we conclude, and we already count the numbers from 0 to 2 pi. Let's do it with another radian, because that one is very easy. Divide by half is not complicated. So how can you count from 0 radians to 2 pi, counting by pi 6 over pi 6? Same idea, just that now you're not gonna divide in half, so you're gonna divide in 6 parts, and that's why we're working with pi 6. Okay, here is the counting. 0, then 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6, 6 pi 6, and something will happen here. 7 pi 6, 8 pi 6, 9 pi 6, 10 pi 6, 11 pi 6, 12 pi 6, and something will happen in that one too. Of course, you can continue counting 13 pi 6, 14 pi 6, but I ask you to conclude into 2 radians. So I'm sure here we fit the 2 radians, the 2 pi radians, because 12 pi over 6 can be simplified. The simplest form of this will be just 2 pi. Okay, we're gonna see it right now. If you see, some of the fractions are already simplified, but many of them need to be simplified. Which ones? For example, that one. That one too can be simplified. If you see 3 and 6, both are divisible by 3. 4 and 6, both are divisible by 2. 5 and 6, no. 5 is divisible by 5, and 6 is not divisible by 5, so no. 6 and 6 both are divisible. I mean, they can cancel each other. 7 over 6, no, but 8 over 6, yes, because both have a half, or both are divisible by 2. 9 by 6, yes, it can be simplified. Both are divisible by 3. 10 by 6, if you see, both have a half, so yes, you can consider those like radians you can simplify. And of course, 12 by 6, this cannot be simplified, it's already simplified. And this is the what you're going to do, of course, in order to make the graph of trigonometric function. So how can you simplify this one? It's easy. You can write 2 6 in your calculator, and your calculator immediately shows you 1/3. Here's the simplest form of that one. What about 3 pi 6 is pi and a half, and so on with the other ones. If you see 5 pi 6, it stays the same. 6 pi 6 is just pi. 9 pi over 6 is 3 pi over 2. 10 pi 6 is 5 pi thirds. And if you can check those values one by one, And this one in here is the counting from 0 to 2 pi by pi 6. You start with 0, 1 pi 6, pi third, which was 2 pi 6, 3 pi 6, which now is pi half. And this is the way to count. I mean, if I ask you to count by pi 8s, you're going to do the same. Start with 1 pi 8, 2 pi 8, 3 pi 8, and so on. Just keep in mind something. To conclude the first pi, you need to reach the same amount of parts that you divide. I mean, here I have pi 6. So to conclude the first pi, I need 6 pi 6. 1 pi 6, 2 pi 6, 3, 4, 5, 6 pi 6 will conclude the first pi. If you see here, that's what we have. We have 1, 2, 3, 4, 5, and in the sixth one, we conclude the first pi. What happened? How do I know that I have to conclude in here? Okay, because I have to conclude the first two bunch of pi 6s that I have in here. I have 6 in here, and I will have other 6 in here. Of course, if I continue 6 more until 18 pi 6, I will be in 3 pi. So this is very important you keep in mind, and this important idea is going to be useful at the moment to make the transformations of sine, cosine, and tangent we will study later. So how can you, here is how. How can you count from 0 to 2, counting pi fifth by pi fifth? If you're not clear at all, count pi fifth by pi fifth means that you need to divide pi into 5 parts. So here you have the distance from 0 to pi and the distance from pi to 2 pi. Of course, I need to divide this in 5 parts. How? Easy. You can use a ruler to make this. Of course, I'm using this presentation in order to show you how this works. So here, if you see, I already divide from 0 to pi into 5 parts. This means pi fifth. Divide pi in 5 parts. And if you see, this is what I have one part in here. So here I will have the first pi fifth. Here the other one, and so on. Of course, you have to continue doing, because if you start dividing by 5, the pi's, the distance between the pi, you have to do it every time. I mean, from pi to 2 pi, you have to make another 5 divisions. And this is what you have. Of course, the numbers that go in there fit exactly like this. Here goes 1 pi fifth. Here goes 2 pi fifth, 3 pi fifth, 4 pi fifth, and the first 5 pi fifth makes you pi. If you see, makes you pi. So who's next? If here was 5 pi fifth, then goes 6 pi fifth, 7 pi fifth, 8, 9, and next one is 10 pi fifth, which is 2 pi. Interesting idea. You can continue counting. Next one will be 11 pi fifth, but we don't need it right now. I mean, I just asked you to count from 0 to 2 pi, but maybe in the work you're gonna do later, you will need it. And what happened to the left of 0? Happens the same, just that you go in a negative, with the negative values. Of course, here it will be negative 1 pi fifth, here negative 2 pi fifth, and so on. This idea is very important at the moment to make transformation of trigonometric functions. So here's a true or false exercise, very easy, very simple. I want you to conclude these exercises quickly. If you can, stop the video or pause the video and conclude if they are true or false. Okay, I'm gonna give you the answer of this, and it's very easy. Of course, you can conclude this very quickly. Here are the answers. Next to 3 pi fourth is 5 pi fourth, false, because next to 3 pi fourth is 4 pi fourth. B, 5 pi 12 is, next to 5 pi 12 is pi and a half. It's true, it's true. I know pi and a half is not related with pi 12, but if you see here, next to 5 pi 12 is 6 pi 12, but at the end this is pi and a half because you have to simplify. Next to 9 pi 10 is pi. It's true, because next to 9 pi 10 is 10 pi 10, which is just pi. Next to 11 pi 6 is pi and a half. Is false, because next to 11 pi 6 is 12 pi 6, which becomes to be into 2 pi. Okay, how's the shape of sine? And keep a lot of attention in this part because you're gonna do something similar with cosine. This is gonna be part of your investigation. You're gonna do it in this way. So we need the list of trigonometric values. Here we have it. Once we have this, we need to analyze what happened with those each of these values. Look, something interesting and trying to conclude this in the graph we're going to do. If you remember, a graph needs points. The points here are made by those values, by 0 and this result, by pi 6 and this result. So practically the coordinates here are 0, 0, pi 6, comma 1 half, pi 4, comma square root of 2 over 2. But something interesting happened with the list of these values. If you see, from 0 until here, those values repeat again and again and again, but just changing the sign. So they follow a pattern practically, and that pattern is that the values of signs start at 0 and then reach 1, and then starts going down until 0 again. Then starts going down until -1, but then return again to 0. This pattern is so important, we will see what these do. So practically, I was saying that the first 5 values repeats in all the values, just that maybe change the sign. And we're gonna have again a decimal approach of 1 half, which is 0.5, just to have an idea how these behave. Square root of 2 over 2, which is 0.70 approximately. And square root of 3 over 2 is approximately 0.86. So this is very important, keep in mind, because then at the moment to make the graph, we're gonna use it. So comparing the values, if you see, if you're clear that square root of 3 over 2 is 0.86 and square root of 2 over 2 is 0.70, the maximum value that this trigonometric function can get is 1. And the minimum is gonna be -1. So let's make an analysis, breaking apart the values. And I have the values in these little groups. I'm gonna explain you why. If you see, I have like 4 parts of this. And reason is because from 0 to pi and a half in this first bunch of values, sine go up. The value, the graph of sine will go up. Then being 1, you start to go down until 0 again. But if you see here, for 7 pi 6 to 3 pi and a half, something interesting happened. Now those values we have in here go but negative. Means that sine start going down until -1. Of course, cannot be less than that. And then for the next part of x, or the next group of values, we have next. Sine go up and reach 0. So to understand this better, because practically this is the unitary circle, these are the unitary circle values you get, we can conclude how is the shape of sine. And the shape of sine needs that you be sure with this unitary circle values, because from 0 to 2 pi, where you complete a circle or a cycle of a circle, you complete a cycle of sine too. And the shape of sine, it's gonna be like that. So like I told you, from 0 to pi half, go up, then from pi half, go down until -1, and then go up again. Of course, this cycle comes from the unit circle. And the translation of those values in the unit circle to a graph is this one. So the shape of sine is like an S, if you see. It always is like this, just that sometimes goes a little bit more than 2 pi or is less than 2 pi. We will see how that happened, and it's not complicated. Of course, you have to do something similar with the graph of cosine. So to conclude the presentation, we need to say that the division of the radians we have in here, it's gonna be needed later, and we will see how can we get this graph specifically getting or using these bunch of values we already analyzed, and how these values will be useful to make this shape. Not complicated. We're gonna do the same with tangent, and it's gonna be in your hands to do the graph of cosine. You will see that not complicated. We'll give you some tools to understand this better. And please keep in mind that you need your unit circle. You need to have it in hand. So please have it over there, and we're gonna use it for next class. So thank you guys. This is all for this first class, and thank you for your time.